the mic.
Sure. Hello and welcome to this session of live interaction for the course called Software Conceptual Design. We will start with first taking a look at some of the assignments that have been submitted, and then we will go on to taking live questions. So Lakshmi, do you want to start with the FBS assignment submissions?
Yeah. Good afternoon, everybody. So we are taking a look at some of your submission. The question there was to create a conceptual design for a mood-based music player and just upload it, what you have created. So what we see is, at top level, we see that some of you have actually, drawn it on a piece of paper, and it's very interesting to see that, and you have uploaded that. Some of you actually used flow charts, okay, to kind of represent the software conceptual design, and we saw this in some of our studies, earlier studies also, that people kind of use flow charts a lot, okay, and on a very other level, some people have actually kind of used some tools. Like some of the conceptual tools that are there on the internet, like Create.io and all that. So that's also interesting. So some of you have gone ahead and created a project document, okay. So I want to now invite Prajish. So Prajish, what do you think is the difference between a conceptual design and one of these project documents that you see here? Yeah, so this is one example of a project documentation.
Okay. So I think project documentation, it is more detailed, and there are timelines given, and when does the project start, what all are the intermediate tasks. So yeah, it's like a project planning type of thing, right? And whereas a design might be just one part of that entire project, and especially for large systems and all, such type of project documentation is very important, because based on that, you have to decide on the budget, you have to estimate manpower, and so many other things, right? So whereas design is maybe one aspect of this entire process. That's what is coming to my mind. You want to add something?
Right. So yes. So I think to summarize, the project documentation includes a lot of things like test plans and user studies, and maybe even some user manuals, which we are not doing at the time of the design of the document, design of the system. So each has its own purpose, and this actually brings us to another interesting point of what are these different types of system. Like, it's not that for every system the design follows the same approach, or you have the same type of documentation. So for example, a mood-based music player is very different from a missile controller, right? So if you stop to think for a moment as to what is the difference, you will realize that if there are bugs in the mood-based music player, at most it may play a song which you were not expecting it to play, right? But you cannot afford such bugs in the missile system, right? So what is important here is to identify what the different which parameters to pay attention to at the time of the design. So I think that is also something which you can use the FBS system to help you zone in on as to which is the most important functions of your system, and spend more energy in designing those systems, those critical systems, and then go on to other systems. Okay, so I see there are 14 viewers logged in, so maybe we can wait for some live questions. If there are some pre questions, we can go to that.
Yeah, so there was a question on, I had missed the submission deadlines of my first two assignments due to some issues, personal issues. So will I be able to receive certificate if I get good score in exams? So Prajish, do you want to take this and
No, I think what you can do is send a mail to the support team, and I think they will get back to you on this. So yeah, I think that is a standard thing which you can.
so moving on, we don't see any questions.
Yeah, I don't see any questions yet.
Yeah.
So,
So I have one more kind of a feedback that I saw. Many of you have kind of, also mentioned uh, one of the things that we see in the assignments is there's a lot of emphasis on one feature of the system, which is only mood detection. And there are, a mood-based music player. One of the feature would be mood detection. But, it has other standard features like ability to log in and, remember a user, generate a playlist. There are other features as well. So, I mean, you want to talk about it, Prajish, that we see this day in day out when people who are novices or people who are first year engineering students and second year engineering students kind of tend to focus on one feature and go in the depth and yeah, do you want, yeah.
Yeah, right. Yeah, so yeah, even in, I think you have done studies with students and you have seen this, right? That, whereas experts or even experienced people owing to experience working in such projects, uh, before they start thinking about one particular feature and what all is there in that, they kind of abstract out or they have a big picture view, of what are the different components and what are uh, the different functionalities, and I think that's what FBS helps us to do, right? And once you get all those big blocks in place, then you can maybe zoom in or go a little more deeper into the connections between different modules and see how those go.
Yeah. So if you use the learning environment think and link, which is in week 2, so what we see there is, there is a person, there is some agent which tells you you can populate the functions in this way, think of all the features of the system, think of how those features will be implemented, what all structures, and think of how these structures will interact with one another. So that is something that, when you create the FPS graph that is there in the week 2, you will kind of get into practice to be able to do that. So that is the idea of, giving a framework for you to think with, so that when you think about creating a conceptual design, you just don't get fixated on one feature and go in depth in about that feature. So would you want to add?
no, I think that is fine. So what I was thinking about is the connection between week 2 and week 3. So what you are learning in this course is use of two different software, and maybe we can spend a little bit of time talking about the connection between how we go from FBS to actual design and design verification using Medicine. Yeah.
Yeah, so and I think in week 4 also we talk about this connection where all these are different abstractions of the system, right? FBS is you are just starting off coming up with a design. You really don't know what are the different parts of the system and you're just exploring. And in that way, I think FBS helps us to get an idea of the entire system, right?
Yeah.
And making these connections and all of that will actually help us do that. But once that level of abstraction is clear, then we can go into a little more detail. We can create UMLs, think of the classes, uh, the functions, the data members, how different classes they relate to each other, and then you have the requirements and your model or the design, and is it matching, right? Are there some requirements which are conflicting with the design or the other way around? Is there something missing? I think Verisym or doing the design tracing, all of that can help you uncover those type of mistakes. Yeah, so that is one thing which came to mind.
Yeah. And also what in these weeks we are giving you are tools to think with. I mean, we are providing you these learning environments which encourage you to be able to think, certain tools and techniques that you could utilize to think with different problems. Like Prajish spoke about starting with FBS and then verifying the design using Verisym. So these are techniques and tools that you could, utilize in any of your different kinds of problems. So there is an answer from Bharti that if students get 10% from the other two remaining assignments, then they will be eligible to give the final exam. Okay. So 15 viewers.
Yeah, so we will now go to interacting with viewers. So we would like to know who these 15 are, and what are the challenges that you are facing in this course. It will be nice if you can put something on the chat and we can then respond. No? Question has come up.
Yeah.
Okay. Yeah. So there is Lloyd Costa. So he's asking, why is the option not enabled even after answering all the questions in Think and Link worksheets? I think Lloyd, you would have to go through the different tabs. The reason why we are not enabling you to move to the next phase is to ensure that you have viewed all the tabs in the current phase that you are in. So if you have, gone through all the tabs in the particular phase, we will move you to the next phase, whichever phase that you're currently in. That is my answer. If you have something very specific, please do put it on the discussion forum and we'll be able to take it up if you have any difficulties there.
Yeah, so I just wanted to related to this. So if you think of Think and Link itself as a software, right? And the people who designed it, so they also would have had, and I know you have designed it. So you would also have some rationale. That's like a requirement of the system, right?
Yeah.
Which you want.
Yeah.
And maybe there is some specific reason why you thought of that also, right?
So I think one thing that I have seen in many of my studies with the learners is that the one tab which is the UML models, okay, so they don't kind of go to that particular tab and then they think that, don't complete viewing the video, which is a requirement for finishing that particular phase. So I've seen that. So if that is what has happened with you, I would recommend you to go to that particular tab, play the video, understand why the video is there, and then complete the phase. And if you have any other questions with respect to Think and Link, feel free to ask Lloyd. I'm glad that you're using the system.
Okay, while we wait for more questions, maybe it will be interesting, like taking off on what Prajish said. Since you designed the system, you can say a little bit about the design of Think and Link and then of Verisym itself. We'll treat them as software systems which we have designed and we know them well. So we can talk about it in terms of the design that we are talking about in the course.
Yeah, sure. So the Think and Link, the functionalities of Think and Link were that,
Not understand FPS frame. Okay.
Example. Okay. So since Mahato is asking what is FPS framework, let me use Think and Link itself to explain the FPS framework. Okay. So the functionalities that are we want the Think and Link to have is some sort of student login and a student specific login, so that we remember where each student was. Okay, that's number one piece if you kind of take. The second piece that we want the student to be able to do is create a representation. The functionality that is there in Think and Link is to create a representation. One form of representation is the graph. Okay, and the other functionality was that some sort of question and answer, some sort of worksheets that are there, functionality for the learner to be testing their own learning. So you are actually doing the worksheets, and in the second phase you will actually be evaluating the FPS graph. So those kind of things. Now the structures that are there across, if you kind of see, is that we have used some libraries for the FPS graph. We have used certain libraries for you to remember the answers, PHP SQL to remember the answers that is there in the backend, have a database, right? And we have also kind of designed it to have a design in the sense that it's a simple design. We have kind of did some usability. We have used CSS and those kind of things to be able to create the design. Now if you look at the behavior, one important aspect that is there in FPS is the ability to interact with whatever you are doing. So there is whatever actions that you are doing, there is a person on the left, there is an agent who kind of gives a comment on what you are doing, what you are intended to do, what you should be doing next. So some sort of interactivity. So if you now kind of see what is the FPS framework, F stands for functionalities and features, B stands for behaviors that you are wanting the system to do and the system is expected to do, and S is the structures that are there. Let's say it could be some logical structures, some algorithm, or some sort of physical structure. Yeah. So this is how I would explain FPS using Think and Link.
That's fine.
Yeah.
Yeah. So next question is, will you provide some insight to dynamic modeling, stateless and state dependent? So unfortunately I don't know much about this, and it's definitely out of scope for our course. Yeah, so what could it be? Stateless versus state dependent modeling.
So yeah, when we talk about state, it is about typically you have the system has to remember something, and right, like even in the design tracing, we have seen the state diagram. It remembers what are the values of different variables and all of that. Uh, so I'm also not very clear about the question. So for example, if it's a normal website, where you're viewing something, right, that is a stateless system where it doesn't remember who the user is. Whereas if it's a login system which requires a login and all of that, yeah, so then maybe that. So, but yeah, I'm not very clear.
Yeah,
In dynamic modeling, yeah.
Exams questions.
Yeah, so it will be a mix of the type of questions you have seen in the assignments, and yeah, some other type of questions. Yeah, the numbers and all, I don't think we can tell. Yeah, but it will be similar to the assignments, so you need not worry about it.
Yeah, so if Garima is there, Garima, can you provide a little more context to your question? If at all you want to ask in what context are you asking this question? It will help us, understand the question a little more better. Ravilochan Mahato, did the answer we provide you, was it sufficient or you need some more examples?
Yeah, we can just wait for a while. Yeah, we can wait for a few minutes to let them think about it and see if they have any questions. Depends on stateless UML diagram, she said.
Yeah, there are two kinds of, yeah, I can, I can take this up. So there are two kinds of UML diagram, if I know. One is static UML diagrams and the other one are dynamic UML diagrams. Like for example, if you take the activity diagram, it's a dynamic UML diagram in the sense it really happens when a particular, let's say for example, even the state chart is a dynamic UML diagram. It happens when there are different values for a particular variable, and then depending on that value the course of action will actually change. But let's say if it's a static UML diagram, one example that I can remember is use case, right? A use case is very static, okay? It does not really like depend on any value of a variable. So these are the two different types of UML diagrams, and if you go into the LXTs that we have provided for UML diagrams, you will see a lot more examples of these two kind. Yeah. Communication interaction diagram is also one of the yeah. Garima, you are right. Interaction diagram is also one of the thing of dynamic UML diagram. Yeah.
Yeah, so Rabilochan is asking about UMLs, right? What is the purpose of UML and can it be only used for documentation? Yeah, so right now if you see many people, just out of compliance, I think many people just use UMLs as a means of documentation, right? But what we are saying through this course is these models, are a very good way of thinking about the design, right? And of course, this will help you to communicate what you want to clients and all of that. But more than that, even you are saying that point that these are tools which we can use to think about our system. So in that way, Rabilochan, I think that UMLs, yes, it can be used for documentation, but more than that, I think if this type of models can actually help you plan and think about the system which you want to build. And even in industry, it's not the case that many people will use UML. Let's say you're going to go to the industry, and it won't be the case that every company will use UML, right? But our aim is to expose you to these models so that whichever model they use, right, in their company, in your company, wherever you join, at least you will, that idea of modeling will be there, right? And that's an important idea which you all should know of if you are thinking of software design.
And you know what Prajish just said, even in FBS and in Verisim, the important aspect that we want to reiterate is this integrated modeling, right? So what really happens, suppose let's say you are using UML only for documentation and you're straightly going to write a code, you will have to, there will be some errors that come up and you would want to change a particular line in a code. So what usually happens is that, if you change line in a code, you need to know what are the cascading effects of that particular change. So if you don't have an integrated view of what the design is, what really happens is that you go and fix something and there are like 10 more bugs that happen because of that one particular fix, right? So the idea is to look at software as an integrated model, and FPS and Verisim and UML are to understand that these things you can think like what Prajish just said.
Yeah, so Rabilochan is asking FBS and UML, is it used only for web-based software or can it be used in embedded software? So, especially for UML, I can say that I think especially for embedded software, safety critical systems and all, in the past, UML has been used, and it has been used successfully because UML in that way it gives you a very detailed description of what should happen and what are the messages which should be passed. It gives you a very nice blueprint of the entire system. And if I want to code it, I just have to look at the model, and there are systems which convert this UML into code directly, right? So that is also possible. So yes, definitely in embedded, in any type of software, UML can be used. Maybe for FPS you can come.
Yeah, FBS, my understanding is that it can be used for all types of software, but like what Prajish earlier mentioned, that when you are exploring and you want to create a design and the problem is still in its nascent stage and there are a lot of unknowns, to explore the problem as well as make inroads in the solution, you can use FBS. But as and when there is a, you have kind of fixed your requirements, and this is where we now go into a whole complete solution, is where you can expand into UML. And like how Prajish said, there are so many softwares these days which can, the more detail you create your UML, it automatically gets converted into a code, and you could do a lot more things there. So that's there, sir. You want
That's
to,
fine.
yeah,
I think that's
yeah.
fine.
So
That's
Ravilo,
it. He said he's asked a question on the syllabus. Research in software domain. What is the research in software domain? If that's your question, then there's a lot of work that people do. So there are different new types of patterns and new types of how to design software more efficiently. So that is one of the areas where there is research going on in software. So you see, the whole idea is that now that we are designing larger and larger software systems, and the fact that we don't have to write all the code from scratch, right? We don't have to do everything. So a lot of research is towards making the act of programming easier and more accessible to non-computer science people, so to speak. So there is that, and yeah, software engineering research. So that is basically what I'm saying. So software engineering research, this is one aspect that you can look at. Another aspect of research in software engineering is in verification. So there is a lot of work on automated testing. So how do you do, like, for now, I think a lot of the automated testing is limited to simple conditions in the program. Like for example, if you take a system which has three variables, each of which can take three values. So right, so you have a 3 raised to 3 explosion that happens when you try to capture the state of the system. Now you want to check whether any of these states is undesirable. So suppose, let's say, you can just think in terms of a binary value. So let's say you have three variables, so it's a 3-digit binary number, and let's say each of them is just taking two values, right? So you're talking about a number of the order of 8, right? So so there are 8 different combinations that you can get. Now which of these are valid combinations, which of these are allowed combinations? So that is one direction in which the research happens, and it's far more advanced than what I'm saying, but I'm just trying to convey the idea right now. So that's the area of automated testing, verification. Then in verification, again, there are a lot of verification languages that people use. So each of them have their own purposes. So that's one area of research. Then software engineering education is one area, right? So how to teach software engineering in a way that students don't find it that, okay, there is something in the textbook, I do something else in the project, and I have to do a third thing in the industry. So somehow connecting all of that, how to do that meaningfully, that's an area of research. Yeah, if there's something you want to add.
So now there are other areas, like there are people who are trying to improve developers' productivity and practices in the software industry, tools for software development, like your how can developers read code better, debug code better. So there is active research happening in these areas also. Human factors in software engineering, all of those things. So one good conference which captures all of this is called ICSE, International Conference in Software Engineering. They have a journal also, Transactions on Software Engineering. So maybe you can have a look at these conferences and journals to get an idea of the work.
And to add what Prajish is saying, now people are also trying to um, look at how collaboration can happen while you're creating, you're doing software engineering, and a lot of tools which aid collaboration, because most of the tools that are there in software engineering is a single user system where one architect is sitting and and doing all this, because now there are teams that are there across the country, how to introduce collaboration. So that is also one of the important tracks in ICSC. Yeah, so that's that question, and this is also one of the question by Ravi Lochan. Ravi Lochan has been asking this question in our um, um, our sheet
Forum.
as well, forum as well, that how to find finite state model from different software artifacts like code, UML, because Ravi Lochan is interested in requirement engineering, to give some. So, Raviloshan, I will start with my take, then I invite Professor Sridhar and Prajish also. So, when we talk about FPS, like we earlier said, FPS is when the problem is still unknown, and you have to what is your approach to creating a solution. You can start thinking in terms of function, behaviors, and structures, in which you define the problem along with the solution. Right, and once your requirements are there and you feel that you have defined the problem well, and you can you can start creating your solution, you will use UML, where all those different class diagram, your activity diagram, and your use case diagram, all those you can create and link each of them. So that's where when there are a lot of unknowns and when you have to start is where you use FPS and UML. But when you talk about finite state model, it's something that when things are fixed, right? So that's my take on finite state model. Yeah.
Yeah. Yeah, so to add to that, see, when you are talking about finite state model, again you are making an assumption that there are some UML models which are already done, which are already given, from which you are now going to infer the finite state model. So one way to do that is to look at what are the variables. Like even in Verisim, in V3, if you look at the way Verisim works, so there is a state model in the system. And if you look carefully what is there inside the state, it's basically the different variables. So the state of any system can be captured by the values that the variables in that system take, right? So that is basically the checkpoint for any system. So if you start with the initial values of the system and you go through the different UML diagrams and say that okay, suppose I am following through an execution, you can imagine it even as a flow chart. It doesn't actually have to be a very complex diagram. Then you can say, okay, these are possible values that my variable can take, and the state transition diagram or the finite state model that you're talking about can be drawn out of that. So the states will be the variables and their values, and the arrows will be the events which cause the transition from one set of values to another set of values. So, like for example, it could also be useful to detect things like deadlocks. Like if your system goes into a set of states from which it is unable to come out. So, how to detect deadlocks? The finite state machine is very useful to do that, because you can easily see the deadlock in that situation. Yeah.
Yeah. Just to add on to that, even for maybe safety critical systems and all, right? Let's say you don't want to reach a state which will cause some serious harm or something bad will happen, right? So in that way, the finite state model, if and imagine if these are big systems which have different scenarios, and maybe a combination of two different events in two different places can cause a transition to a state or an undesirable state, and such things can also be detected by the finite state machine. Yeah, and I agree. So I think so if your question is, do we need to draw a state diagram for all software which we design? Definitely not, right? So different types of softwares have different purposes, and And I think we have explained in week 3 also that you need not use all the UML diagrams or all the modeling techniques for any problem which you design, right? All these are tools, and based on the requirements or based on the goal of the system, you can use these to come up with a model.
I think that's it. If there are no more, we'll wait for some time. So we'll wait for some time to see if there are any more questions. From our side, we have finished talking about whatever we wanted to say. So we'll wait for 3 minutes to see if there are any more questions. Okay, one last minute to see if there are any more questions. Exams are MCQ questions.
Yeah. Yes, it's mainly MCQ. Yeah. Yeah, you won't be required to write long answers or anything.
We already answered that, I think. Just repeat. Okay then, if there are no more questions, I think we can stop here. And thank you for joining us today for this live interaction session of software conceptual design. So wish you all the best for the remaining week and the upcoming exams. Thank you for joining us.
Yeah. Okay. Thank you.
Thank you.
Everyone.
Thank you, everyone. Thank you.